Okay, we've talked a lot about systems of equations. Now I want to talk about, and if you remember back in the video where I talk about graphing, I asked the question, what would happen if the lines never intersected? What would that solution look like? Well, that's what we're going to talk about today. So first, really, I just want to talk about, or what we've been talking about with substitution and elimination and solving by graphing, is when our systems have one solution. There we go. Where our systems have one solution. Right, and that's your basic just, I don't know, you have two lines and they intersect, right? And then your solution is the point where they intersect, right? That's we've talked about that quite a bit. So that's when systems have one solution. It's where not graphs, where graphs intersect. And if we're looking at the equations of these types of systems, we'll notice that they have different slopes. Okay, so every single system of equations we've looked at so far has had, the two equations have had different slopes. The lines of those graphs would have different slopes. So now we need to talk about what happens when the slopes are the same. Well, there's two outcomes when the slopes are the same. The first is that there is no solution. So here's an example of a problem that you might see. And let's look at it two different ways. How would you solve this problem? Y minus 2x equals 6. Y equals 2x minus 4. Well, because there's a graph here, you might think to graph, which we totally could. Right? Add 2x to both sides and we'd get y equals, maybe I can do a different color for this. If I add 2x to both sides, I would get y equals 2x plus 6. And then we could graph both of these. 2x plus 6 is here, and our graph, again, we might want to use red. Our graph would look something like that, I think. Okay. So, and then I could graph my second equation, 2x minus 4. So here's 4, that's our starting point, and we go up 2 over 2. So 2, 2, 2, 2. So we do something like this. And notice those lines are never intersecting. They never intersect. Another name for those is parallel lines, right? So if my lines never intersect, then we have no solution. So here the solution would just be, if you were to see this, what's the solution to this system of equations? The answer is no solution, right? That's the answer to this question. Now, we could also solve this by substitution. I'd like to check that out. Since y is 2x minus 4, I could substitute in, I could substitute in 2x minus 4 for y. 2x minus 4 minus 2x equals 6. Okay, if I simplify here, I have 2x minus 2x, which is 0. And then I'm left with negative 4 equals 6. Does negative 4 equal 6? No way, it does not equal 6. So therefore, there is no solution because we get an untrue equation, right? We can't substitute that in because it's not true, right? Negative 4 does not equal 6. So we'll fix that to the not equal sign. Okay. So that's when we have no solution, the lines are parallel. Another way to say this is that this is when the slopes are the same, but the y-intercepts are, that S could be closer, I think. The y-intercepts are different. So when we have the same slope, but different y-intercepts, that's a system with no solution. Okay, there's one more type that we'll look at for linear equations, and that's when we have infinitely many solutions. Okay, so if I have infinitely many solutions, that means that, well, let's just see. I give you this equation right here. Negative 4x plus 2y equals 6. Negative 20x plus 10y equals 30. Well, this lends itself, makes me think I would use elimination to solve a problem like this. So I'm going to multiply this top. I want to cancel out either the x or the y. And if I multiply this negative 4 by 5, I'll get negative 20. So I'm going to do that. Multiply that whole equation by 5. So that would leave me with my new equation, negative 20x plus 10y equals 30. Okay, I'm already seeing some weird things here, but since these are the same, I need to subtract. Let's go ahead and subtract and see what happens. Negative 20x minus 20x is 0. 10y minus 10y is 0. And 30 minus 30 is 0. So I get 0 equals 0. Now, unlike the last time where I got a number equals a number, this one's actually true, right? And if you noticed earlier, maybe you saw that these are the same equation, right? Negative 20x plus 10y equals 30 and negative 20x plus 10y equals 30, that's the same. So if you have an equation that has the same slope and the same y-intercept, then that has infinitely many solutions. So we can graph this, right? I'm going to go ahead and solve here. Let's solve for y and graph it. If I can get this working, okay. So if I add 4x to both sides, and this is just because I want to graph it over here. If I add 4x to both sides, I would be left with 2y equals 4x plus 6. If I divide both sides by 2, I don't know, maybe we can get like some pink in here or something. Divide both sides, oops. Okay, divide both sides by 2. Y equals 2x plus 3. Okay, so graphing that, loving 2x today. Okay, so 2x plus 3, 2, 2, down 2 over 1. Okay, so something like, oops. Something like that. Pretty good. Okay. Now, what would happen if I solved for y here? Well, kind of running out of room a little bit, but if I were to solve for y in this equation, right, add 20x to both sides, 10y equals 20x plus 30, divide both sides by 10, and again, I get y equals 2x plus 3. So that's the same line, right? That's the exact same line that I just had. So that means that instead of intersecting just at one point, these two lines intersect at every single point. And that's why we say they have infinitely many solutions. So the three types of systems you can have. You can have systems with one solution where they intersect, where the graphs would intersect. It's when the graphs have different slopes. You can have graphs with no solutions, right? No solution. That's when the graphs have the same slope but different y-intercepts. Or you could have a graph with a system with infinitely many solutions. It's where the graphs have the same slope and the same y-intercept.